So what is the product rule of differentiation? So when we're given a function, let's call it h of x, and h of x is equal to f of x times g of x. So if we're given a function that is the product of two separate functions, then to differentiate it, or to find the derivative, right, to find h prime of x, we're going to have to find the value of f prime of x times g of x plus f of x times g prime of x. And you can also think of this as the derivative of the first, right? So we can call that first prime times second as it is plus first as it is times derivative of the second, or second prime. So how do we know when to use the product rule of differentiation? So it's pretty easy to identify usually. You're going to want to use the product rule to find the derivative of a function whenever the function, right, like we said in the definition, you're going to want to use the product rule whenever you have to find the derivative of a function that's the product of two functions. So what that might look like is f of x equals, let's say, 2x minus 3 times x squared minus 2x plus 1. Or if it looks something like f of x equals sine x times 2 cosine x. Now let's try an example. So we're given f of x equals 2x minus 3 times, and because it's times, because we're multiplying, we're using the product rule. So f of x equals 2x minus 3 times x squared minus 2x plus 1, and it wants us to find the derivative. So let's think back to what the definition was for the product rule. H prime of x, right, so the derivative, what we're trying to find, is equal to f prime of x times g of x plus f of x times g prime of x. So let's keep this in mind while we set this up. So first, if we're trying to find f prime of x, we first have to find the derivative of the first, right? F of x and this are equivalent. We'll just call them the first, right? These are both the first. And then this is the second, and g of x here is the second. So the derivative of the first is just 2. So we have 2 times, and now g of x is just as it is. It's not g prime of x, just as it is. So the second as it is, x squared minus 2x plus 1. And then we're going to add f of x as it is. So that's 2x minus 3, right? We're adding, this is the first and this is the second. So we're adding the first as it is, so just 2x plus 3, times g prime of x, so the derivative of the second. So we'll differentiate the second, and we get 2x minus 2. So now we've completely set it up, and all we have to do is FOIL and simplify. So this becomes 2x squared minus 4x plus 2 plus, that's not right, multiply the 2x times the 2x, and we get 4x squared, and then minus 6x, and minus 4x, and then multiply the negative 3 and the negative 2, and we get positive 6. So now let's see what like terms we can combine. So we have 2x squared and 4x squared, so that becomes 6x squared. And then we have negative 4x, negative 6x, and negative 4x. So that's going to become negative 14x. And then we have 2 and 6, so that's going to become 8. So this is our final answer. So we can say that f prime of x is equal to 6x squared minus 14x plus 8 by the product rule. Let's try another example. So here we're asked to find the derivative of x cubed times sine x. So because it's times sine x, right, because we're multiplying, we're going to use the product rule again. So remember the product rule. Let's just write it down one more time. H prime of x equals f prime of x times g of x plus f of x times g prime of x. So this is the first, this is the second function within f of x, and this is the first, and this is the second. So first, let's find the derivative of the first part of the function. So let's go ahead and write f prime of x equals, so the derivative of x cubed is 3x squared, and then we're going to multiply it by the second function as it is, so 3x squared times sine x. Then we're going to add that to the first function, first part as it is, which is just x cubed, and we're going to multiply it by g prime of x, or the second derivative of the second. So the derivative of sine x is just cosine x. And looking at this, we can't simplify anything any further, and we can't combine any like terms. So this is going to be our final answer. So f prime of x equals 3x squared times sine x plus 3x, or plus x cubed, times cosine x. So here's another practice problem. You can go ahead and pause the video and try it on your own. So the first thing we should notice about this is that there's a plus sign, right? We're adding. So that means we're just finding the derivative of this and then adding it to the derivative of this. That's right. And if you start with that process, you would find the derivative of 3x first and find that it's 3. And then we would be adding it to the derivative of x sine x. And then we get stuck because here, for this part of it, we have to use the product rule. So let's start by using the product rule to find the derivative of x sine x. So let's write our function here, x sine x, and we want to find the derivative of this. So let's first find our first and second part. So x is our first part, and sine x is our second part. So let's start by using the definition of the product rule and finding that the derivative of the first part is just 1, right? Derivative of x is just 1. And then multiply it by the second as it is. So we have 1 sine x, and then we're adding that to the first as it is, so just x, and multiplying it by the derivative of the second. So the derivative of sine x is cosine x. So now that we've found this, we see that we can't simplify this any further. But remember, this isn't our final answer because we still have this 3x. So now, let's finish it all up, and let's do f of x, or f prime of x, equals the derivative of this, so that's just 3, and then plus, right, plus the derivative of this, which is right here, so plus sine x plus x cosine x. So this is our final answer. Okay, this time it's asking for us to find the value of the derivative of this function at a certain point. In this case, it's pi. So you can go ahead and pause the video and try it on your own. Okay, so we know we're using product rule because we're multiplying the square root of x by sine x. So first, let's take the derivative of the first part, right? This is our first part, and this is our second part. So let's take the derivative of our first part, which derivative of square root x is 1/2 x to the negative 1/2, right? Because square root x is the same as x to the power of 1/2, so we move this to the front, like multiply this 1, this invisible 1, by 1/2, and then subtract 1 from the exponent. So we have the derivative of the first is 1/2 x to the power of negative 1/2 times the second as it is, so just sine x, and then we're adding it to the first as it is, so we'll write that as x to the power of 1/2 times the derivative of the second, or cosine x. So now what we can do is we can start simplifying and rewriting things. So we can go ahead and rewrite 1/2 times x to the power of negative 1/2 as 1 over 2 root x, right? Because we put this x down to the bottom with this 2, and then to the power of 1/2, because that makes this exponent positive, and then x to the power of 1/2 is root x. So we have this times sine x, and then plus just root x, we can write that as root x, times cosine x. So now let's start plugging in pi. So we can kind of just write over like this, pi, 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 and pi. So sine pi, right, on the unit circle, if we have, here, let me move that. If we have sine of pi, and this is our unit circle, not a very good unit circle, but 0's here, pi over 2 is here, and then pi's here, 3 pi over 2, and then this is also 2 pi. So sine of 2 pi, so the y value at 2 pi is 0. So because we know that this is equal to 0, then whatever this is doesn't matter because it's multiplied by 0, so it's going to equal 0. So this side is going to equal 0, and then we're adding it to root pi times cosine pi. So, wait, okay, I accidentally said sine 2 pi, I meant sine pi. Sine pi is still 0 though. So cosine of pi, so the x value at pi is -1. So we're going to have -1 times root pi. So 0 plus negative root pi is just equal to negative root pi. That is our final answer. So here's a couple more practice problems. You can go ahead and pause the video and give them a try, and then I'll show the answers in a few seconds.